to these notes today. We're going to call it Chemical Reactions 4. We're going to hydrocarbons. So we are naming hydrocarbons. We're discussing what are hydrocarbons. And hopefully that helps. Alright, so this word, hydro and carbon. Well, clearly carbon is carbon, right? What do you think of when you see the hydro part, though? Water? Why do you think of water? Hydrogen. Water has hydrogen in it, right? So that is actually what we should think of when we see that hydro. Okay, hydro, water has hydrogen in it. Hydrogen is what we get from that, and that's it. You're like, no, it isn't, and you're right. There's a lot more details to it, but hydrocarbons are molecules that have just carbon and hydrogen. So there's a couple of things to that, and we're going to need prefixes again. So if we have just carbon and hydrogen, why don't we just call them just hydrocarbons and leave it at that? Well, there's a lot more to it because you can have one carbon, you can have two carbons, you can have three carbons. And that's where the prefixes come in. Prefixes tell us how many carbons. Okay. And you would think chemistry would make it convenient on us and just use the same prefixes as we have used before. But not so much. So we have one carbon, we're going to start out with the prefix meth. Don't go anywhere else in your mind. If we have two carbons, we're going to have the prefix eth. Don't ask me how I add a carbon and take off a letter. I don't know. But three carbons, we're going to have prop. And you might have heard, how many of you have heard of propane before? What you get your gas grill filled up with? Alright, that's propane. That's a hydrocarbon that we're going to talk about here in a second. If we have four carbons, we're going to call it butane, or butene, or butine, but we'll get to that. We have five, it is pent, so there's one that's familiar. We've used that before. 6 is hex. 7, and you cannot see what I'm writing. 7 is hept. So once we get to 5, they're pretty familiar. 8 is oct. 9 is non. And 10 is dec. Okay. So the prefix tells me how many carbons I have. And oh wait, I'll give you a second to catch up on that. So let's look at some examples over here in this space. The first example we look at, this is the most common. Hydrocarbon. Methane. So how many carbons do I have if it's methane? I have just one carbon, right? So methane actually looks like this. So what's the formula for methane? There's one carbon, right? We know that from the meth part. And then there is 4 hydrogens, which we don't really need that one, but alright, let's look at another example. Ethane. How many carbons am I going to have? 2, so I know my formula is going to be C2. And then we're gonna talk about this, and you're gonna derive a definition here in a second. So how many hydrogens do I need for ethane? 1, 2, 3, 4, 5, 6. Okay, let's look at, this one's really similar, so I'm going to put it on the same line. But I want you to tell me what is different. What is different? That E, right? So we know that we're going to still have 2 carbons because we start with F, but let's look at how is ethene different than ethane. Well, in ethene we have 4 hydrogens. What do you notice that's different? Huh? Right here, yep. We see a double bond. Alright, check this one out. This is Ethyne. So make a prediction. What do you think is going to be different with Ethyne? We know that we're going to have 2 carbons, but let's look. Notice that triple bond right there? So when we look at that formula for ethyne, we have 2 C's and we have 2 H's. So the prefixes were pretty straightforward. The suffix part, we probably need to discuss just a little bit. So let's talk about the suffixes. Put it right here. I'm going to say and something here, but notice the H's. With ethane, we only have single bonds, and we have 6 H's. With ethene, we have double bonds, and we have less hydrogen, 4 H's. With ethyne, we have a triple bond and even less H's. Why does the number of hydrogens go down when the bonds between carbon go up? Remember, carbon can only make 4 bonds. So we need less hydrogen to satisfy carbon's needs. So suffixes tell about bonds and hydrogen. Alright, so, and they go in kind of families. Oh yeah, that's an and sign, sorry. So, alkanes have only single bonds. These guys are the least reactive. That's just bonus information. Okay. Have only single bonds with the carbon. That's the big deal there. Alkenes have double bonds somewhere. Now, let's kind of clarify that one. If I have 2 carbons, it's obvious that the double bond is going to be between the 2 carbons. But what if I have 10 carbons? There's not going to be a double bond between every carbon. You just have one double bond somewhere in the structure. So only, we're gonna go ahead and put only needs one. Okay. And then the last, well, sort of, alkyne that Y, so it's going to be really, really specific that you say these properly and that you remember. Spelling absolutely counts with these guys. Ane, ene, and eine. Alkynes have a triple bond somewhere. Okay, again, it only needs one triple bond to count. And these are the most reactive. So you might get questions of the hydrocarbons, which kind of hydrocarbon is the most reactive? Well, alkynes are the most reactive, alkanes are the least reactive. If you think about the alkane, their single bonds are pretty sturdy. There's not a lot of stress on that bond. But a triple bond, we kind of talked about stress on the bond, those electrons are trying to push each other apart anyways. So it's important to remember that is still happening. Electrons are still pushing each other apart. And then I'm going to throw another one in there. A lot of times with hydrocarbons, you will also have, you will have an OH group in there. So we're going to talk about them for just a second. Alcohols. These are also called hydroxyl groups. That's just bonus. Okay. This is an OH group, takes the place of a hydrogen. So that's going to end in OL. So let's get an example of that real quick. We saw methane, right, up here. So let's look at methanol down here. So now what does that look like? I'm going to have the C, the central atom, 3 H's. We know from the name there's only one C, also from we have a formula here. But then one of the hydrogens is an OH group instead. It's a pretty common structure. And when you see a formula like that, just knowing that this OH group is going to stick together will help you write them a little bit better. Alright. Let's go ahead and do a couple of examples, and then I'll let you do the short answer part. Okay. I'm trying to think here. Let's just move over so we can switch back and forth. Let's name these. I have C6, H12. Well, how am I going to go about that? First of all, I'm going to think, well, how many carbons do I have? I'm going to come back. My prefixes tell me how many. I have 6 carbons, so I'm going to start with hex. I'm going to come back. I'm going to say, all right, this is hex something. Now, I don't know if it's hexane, hexene, or hexyne yet. So I have to look at its structure. I'm going to go ahead and draw it out. I have 6 C's. 1, 2, 3, 4, 5, 6. Alright, and I only have 12 hydrogens. Well, I know that carbon needs 4 bonds. So if I put a hydrogen here, and here, and here, this hydrogen's satisfied. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I need 2 more. So what happens is I know that there needs to be a double bond there. So now I have 1, 2, 3, 4 around that carbon, 1, 2, 3, 4 around that carbon, and all of the other carbons have 4 as well. So now I can say, well, there's got to be 1 double bond in order for this number of hydrogens to work. So I know that I have to have an alkene ending for my double bond. So this molecule is hexene. Okay. Give me a thumbs up if that makes sense. Okay. Sideways still? Okay. Alright, let's do another example then. Let's go with C4H10. Well, first thing I know, I have 4 carbons, so I come back to my prefixes list, and I know 4 carbons is going to start with bute. Okay. And then I think, well, okay, let's draw it out. 1, 2, 3, 4. I know my hydrogens have, let's see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I had enough carbon to satisfy all of my, I had enough hydrogens to satisfy all of my carbons, so I only need single bonds. That is an alkane. So I know that the name of this molecule is butane. Okay. Now that is what you need to know for our purposes. There's a couple other words we can put in there. If you notice, I had enough hydrogen to satisfy all my carbon. So this is called saturated. Okay. This one up here, so this is saturated. I have enough hydrogen. This one, okay, if this is saturated, what do you think this one's called? Unsaturated. Right. And so you probably have heard things like unsaturated fat, right? That's where this word comes from. So that's great. This is unsaturated, not enough hydrogen. It's going to cause kind of kinks in the chain. Alright, same concept here. Alright, one more example and then I will stop talking, I promise. We will go with, let's do a hard one. C4H9OH. So we'll bring in that alcohol concept. Well, now conveniently, we know that we're going to start with bute. And I'm suspicious that we're probably going to have an ane. So let's go ahead, because we had 10 here and they all fit. So one of them got replaced with this OH group. So I have butane, but this is an OH group. So what did we say? Alcohol is a hydroxyl, and OH takes the place of an H and ends in OL. So our name is actually going to end in OL because we have an OH group replacing one of the hydrogens there. Okay, butanol. So just being mindful of that OL is a alcohol. Okay, you might see on the gas pump. Okay, you might see other places the OL ending, ethanol, methanol. Okay. So that's because the OH group took the place of one of those hydrogens. All right.